Welcome to the Geospatial Intelligence Podcast. My name is Aybars Öztuna and I'm the founder and CEO of Geospatial Intelligence Institute and Master of Science in Geospatial Intelligence candidate at the Johns Hopkins University. Geospatial intelligence, an emerging field. We'll be talking everything about it. Let's begin. GIS in applied mathematics, geometric and algebraic applications, and artificial intelligence. Geographic information has always been a very crucial part of the information industry. Geospatial information tends to have social as well as market value because of its strong correlation with economic, social, and humanistic information. What multiplies its importance is the fact that the information is retrieved through the application of technology that is integrated through the use of spatial coordinate system. The GIS systems that are currently in use tend to provide several services to application systems, but unfortunately, they lack the ability to provide much faster and more effective intensive space computing. The GIS application software programs that are widely used are ArcGIS, MyGIS, and GeoStar. They are eccentric to server or desktop mode in architecture applications using single calculation. The computer power of GIS is unable to meet the complex computerized calculations of intensive geographic computing needs. There are various types of algorithms used in the processing of various types of geospatial data, such as 2D and 3D data. Thus, there is a need to incorporate a new computing architecture for extensively complex computation in GIS. Remote sensing images include specific geometric features and properties. For element extraction in geographic scientific research, there is a need to implement complex geospatial algorithms that deal with an extensive number of geographical observation data for obtaining relevant geographical elements. When these complex geospatial algorithms are implemented, they make the extraction of elements highly computationally intensive and include objects from satellite images, high-resolution satellite image denoising, water storage and processing, energy storage and processing, information related to land. The aforementioned data is derived through the application of various sensors and time data sources. The traditional single service processing model is not efficient in meeting the required data storage and processing demands. Geospatial simulation of the dynamic changes in the Earth's systems thus carry a very extensive degree of computational complexity. For example, simulation of the surface water cycle tends to carry a variety of complex system calculations, which are the measurement of the ocean tide softness, earthquake magnitude measurement, measurement of dust storms and rivers. This periodic simulation needs more than one iteration if we take into consideration the data performance in different time segments, which usually requires heavy calculation and extensive time consumption when doing so. This is one of the main reasons why researchers require highly functional and exceptionally performing computing methods with the ability to boost geospatially computationally intensive problems. The model's calculation generates the calculated results after a reasonable period of time. Geospatial artificial intelligence, which is GeoAI, is an advancing scientific discipline with the ability to combine innovations in spatial science with artificial intelligence methods in machine learning, data mining, and high-performance computing that help in retrieving knowledge from extensive spatial data. Explore modeling is a frequently utilized approach in environmental epidemiology, which helps in conducting exposure analysis crucial for determining exposure distribution in study populations. GeoAI technologies allow the provision of significant advantages for exposure modeling in environmental epidemiology, which include the ability to incorporate large amounts of big spatial and temporal data in a variety of formats, computational efficiency, algorithm flexibility, and accommodation of workflow by incorporating spatial elements that are relevant, such as spatial, non-stationary, and other environmental exposures, model scaling in a vast geographic area. The goal set to do the aforementioned is the provision of concepts around the evolving interdisciplinary field of GeoAI, which includes spatial data science, machine learning, deep learning, data mining, and recent GeoAI applications in research. Geometric algebra includes the provision of a centralized and brief homogeneous algebra framework that is founded on advanced geometric invariance, projection geometry, and affine geometry. It has the ability to provide solutions in the processing of geospatial data, all thanks to the enhanced geometrical vector-based data processing that it has. Geometric algebra does have important applications that make its utilization essential in almost every field, which includes geometry, theoretical physics, and digital image analysis. It wouldn't be wrong to state that geometric algebra is an integral part of international geometric algebra research, with its applications experiencing significant growth in every scientific field, be it computer science, physics, or electrical engineering. Hildenbrand et al. Developed Gallop Web for MATLAB, which provides assistance in robotic arms industrial applications. GIS in astrophysics and astronomy. GIS can be utilized in the field of astrophysics in the following areas. GIS can help in deep space sky mapping through the utilization of mapping software having a 250,000 star NASA SkyMap database and 18 million star guide star catalog and a Saguaro deep sky database with about 10,000 objects alongside 10,000 asteroids and comets. GIS helps in accessing interactive views of both the Earth and the Sun. Map a Planet is an event where GIS is heavily used and is hosted by the USGS Astrology Research Program, where thousands of visitors can have access to the images extracted from various planets and a customized map created through this imagery. It has helped in creating Google Earth, where the universe can be explored just one click away. It provides zoomed-in views of galaxies that are far away. It is a platform where constellations can be explored, planets can be seen while in motion, and supernova explosions can be witnessed. It helps in generating data and maps from the USGS PIGVAD website. GIS in artificial intelligence. In the past few years, we have witnessed a great advancement in artificial intelligence. With each passing year, AI has become so advanced that it has surpassed the rate of human accuracy in image recognition tasks, reading comprehension tasks, and the translation of the text. Generally, AI is considered the computer's capacity for the accomplishment of a task otherwise carried out by human intellect. Machine learning has the ability to turn ideas into possibilities. Machine learning enables learning from data through the utilization of data-driven algorithms, which provide the answers that you are looking for. Deep learning is a newly invented phenomenon. This machine makes use of neural networks generated by computers, which then replicate a human's brain when solving problems or making predictions. The convergence that both AI and GIS are experiencing has paved the way for countless and previously unthinkable possibilities. AI GIS can be referred to as a group of technologies that have the capability to correlate AI with GIS applications or operations. These operations include spatial data processing as well as analysis algorithms, which is GeoAI. GeoAI is a technology that aids in the processing and analysis of spatial data by incorporating artificial intelligence algorithms. GeoAI is segmented into two categories: geospatial machine learning and geospatial deep learning. When a scientist applies geospatial machine learning in ArcGIS, it enables them to process and handle a variety of GIS applications and challenges that may occur when using such applications, such as geographical clusterings, spatial regression, and spatial classification. However, the geospatial deep learning algorithms in ArcGIS include 3D data analysis and image analysis. AI for GIS can be referred to as an artificial intelligence application that is applied in order to introduce an enhancement to the intelligence of GIS software, such as AI attribute collection, AI survey and mapping, AI cartography, and AI interaction. GIS tends to boost AI through the use of its geographical visualization and spatial analytic capabilities, which help it in carrying out further procedures and mining data when AI recognition findings are incorporated into it. Traffic flow monitoring and city component management are two examples of map visualization applications that have provided decision makers with an intuitive form of information expression by conducting in-depth AI extraction, processing, and mining, providing real-time geofence alerts, vehicle training, and other relevant applications. If you would like to have a variety of sources, feel free to follow geospatialintelligence.org. That is geospatialintelligence.org. My name is Aybars Öztuna, and this is the Geospatial Intelligence Podcast.